Okay. A very good morning to everyone, our friends of SEARADO and other regions as well. Thank you for taking your time and effort out to be here for this webinar. Okay, as all of you all know, that today's webinar is on ABP APMU, also known as the Athlete Biological Passport and Athlete Passport Management Unit. So we'll touch on topics such as a brief history of ABP, the two modules available on ADAMS, namely the hematological and steroidal module, your role as a NADO, the functionalities of APMU on ADAMS, as well as the future of ABP. Before that, there are some housekeeping matters. Okay, please note that the webinar will be recorded. Please switch on your video and mute your audio during the session. You can unmute yourself at the end of the session to ask any questions for the speakers, or you can put your questions into the chat box. Now I will call upon Mr. Gobi to introduce our speakers for today. Mr. Gobi, please.
Thank you, Sue. Hi, everyone. A very good morning to all of you. It's really amazing to see all of you here representing the region, and we got people from out of the region. Without further ado, let me introduce the speakers. We are in fact extremely fortunate, I must say, to get these two individuals who know the thick and thin of APB to come and share with us their thoughts. First, I will introduce Dr. Reid Aikin. Dr. Reid Aikin is Associate Director in the Department of Science and Medicine and WADA, where you oversee the Athlete Biological Passport Program. So you have the man himself here. Dr. Aikin, as a background, did his undergraduate and graduate studies in biological sciences at McGill University in Canada, followed by a postdoctoral fellowship at the University of Nice in France. Now, he has been in WADA since 2014, where his roles include overseeing the scientific development of the APB and developing the global use of the APB. All right, so a good experienced person who knows the background from the history and everything right up to now. The next speaker we have is Dr. Norbert Baume. All right, Norbert did his master's in sports sciences at the University of Lausanne, Switzerland, followed by a postdoctoral fellowship in sports physiology at the University of Auckland in New Zealand. His PhD in life sciences was performed in the Swiss Laboratory for Doping Analysis in Lausanne on detection of anabolic steroids in anti-doping, which we have seen happening in this part, athletes getting caught for anabolic steroids. In terms of career, he was with the Swiss Laboratory from 2007 to 2010 as a chief operational officer there at 2010 to 2016, and a deputy director at 2016 to 2019. And following which, in 2019 till now, he has been the manager overseeing the Athlete Biological Passport. All right. Without further ado, Reid, Norbert, over to you. And I will also strongly let everyone know, mute your audio, you can on your video. All right, Reid, Norbert, to you.
All right, thank you very much, Gobi and Soyi, for the kind introduction, and good morning, everyone. It's a pleasure to be here speaking with you all for the next hour and a half or so. Can you just confirm with a thumbs up that you can see my screen yet?
It's coming up. Yes, beautiful.
All right, perfect. So the idea is to really give an overview of what the Athlete Biological Passport is as a tool, hopefully demystify it a bit and show you that it's really one of many anti-doping tools that is involved in the daily work of an ADO, and try to show you the different roles of the stakeholders, from the ADO to the APMU and the experts, and how everyone functions as a combined team to really make the ABP work. And so the talk will be broken down into 3 main parts. I'll start off describing a bit where the passport came from, what it's used for in general, and then Norbert will go over the roles of the different partners in the ABP process. And then we'll finish with a bit of discussion of atoms, the workflow, and then try to show you some concrete cases so you can really get a sense of how the ABP works in practice. And I think as Goey mentioned, for questions, please don't hesitate. If it's really urgent, I'm sure you can interrupt me during the talk if something is not clear, and otherwise, feel free to ask questions at the end of the sessions. And we're off. So I think a good place to start is always, this famous sentence of protecting the clean athlete. And when we think of different tools or programs within anti-doping, it's important to know what the target is and what the outcome is. And as you know well, we can do a lot of things, and even catch a lot of dopers, but without really protecting the ability of a clean athlete to win, or increase the likelihood of a clean athlete to win a competition. And so what we're really trying to do with many of these anti-doping tools is to reduce both the prevalence of doping, so the number of people doping, and as well the effectiveness of the methods or substances they can use. So really try to restrict what is available to those who still wish to try to dope. And so, as you can imagine, when there's lots of people doping with very effective substances, up in the top right here, there's a low likelihood of a clean athlete winning. And when we reduce the prevalence and reduce the effectiveness of the substances they can use, we're increasing that likelihood. So this is really what we're trying to do, is shift towards that higher likelihood of an athlete winning. And so the ABP is just one of these tools, between testing, investigations, the ABP, and education, are all key programs that are harmonized through the World Anti-Doping Code. And so what I'd like to describe today is how the ABP fits into your programs, and how you can use it to inform these other aspects of an anti-doping program. So when we think of testing and ABP, we do think of anti-doping rule violations, and really the 2 that we'll discuss the most today are the first 2. So if you're familiar with the codes, it's 2.1 and 2.2. So 2.1 is where we're detecting the presence of a substance, whereas 2.2 is where we can establish the use of a substance. So it's a legal framework that allows us to establish that an athlete used the substance without detecting the presence of a substance. And so when we think of the passport, often we think of this type of anti-doping rule violation as being the kind of central legal framework. However, I hope to show you that we can use the ABP to really drive almost any kind of ADRV, and we'll show examples of how it can be used to show tampering or other types of complicit acts, team doping, and so on. So it's more than just a tool used to establish the use of a prohibited substance. Another way to think of the difference between the use and the presence, the detection of the presence of a substance, is to think of really a cause and effect relationship. So when we detect a substance, we're detecting the cause. We're really detecting the doping agent. Whereas with the passport, we're measuring the effect. So we're measuring a biomarker, so something downstream. So somebody took a steroid and it activates pathways in the body, and there's some response. So that's what the ABP is trying to do, is measure the response of those doping substances in an individual. One of the first questions is, why do we even need to do that? You know, detection works well. Why don't we just stay with detection? Well, as you are likely aware, some substances are just not easy to detect, either because they're chemically, you know, very similar to something that's already in the body, so we can't really discriminate, or they're rapidly metabolized. You know, like growth hormone doesn't stay around in the body very long, so it's very hard to detect the administration. And then finally, there's new substances that are being developed all the time. And so we, you know, only focusing on detection is limiting in many ways. And so the image here that is shown is to just show you the way that recombinant EPO, so something that a doping athlete would take, how it can differ in lane 1 to what is normally found in the body. And if you only compare lane 1 and 5, you could see, okay, these are different enough that the lab can separate them. But unfortunately, in the middle, you see the range of these designer EPOs that are harder to distinguish from the normal endogenous EPO. And so these are out there. You know, we know there are substances that are very difficult to discriminate from the endogenous substances. Okay, so biomarkers are useful, but how do we do it? How do you use a biomarker to infer that doping took place? And one of the first problems they realized when trying to do this is that, well, everybody is inherently different, and not just on the outside. You know, as much as we say someone is tall or someone is large or different colored skin, there's equally or many more differences inside people. And so one of the first attempts to use biomarkers was to use the hematocrit level, you know, the 50% hematocrit they did in cycling. And of course, what they realized very quickly is some people are naturally higher than 50%. So what do we do with them? And it's the same for other thresholds, for the testosterone to epitestosterone ratio, the famous TE ratio. They also tried to just set a threshold, and it didn't work because some people are naturally higher. So this was one of the major issues that had to be overcome. And as you may be aware, well, the way this was overcome was with this, what we call the passport approach. And so this image here really shows you what the passport is doing. You have the athlete samples in the blue lines here, where each dot is a different sample. And you can see in red, there's an algorithm that is calculating limits that are personalized for that individual athlete. So as you can see on the first sample, we don't know anything about the athlete's normal values. So you can see the range is quite wide on that first sample. The red dots are quite far apart. But once we've sampled the athlete once, now the algorithm can learn where the athlete's natural values are and will begin to narrow. And what this does is gives it very sensitive detection to doping. So if you remember, the population limits that have been tried for TE have been 4. So they tried just setting it for everybody way up here at 4, or even 6 at one point. It was that high. But you see, for somebody like this, that gives them still a bit of a room or a margin to dope. Whereas with these passport limits here, we get a much more sensitive detection of changes. What's important to realize here is that the passport, so we're going to look at, you'll see cases where the blue dots are outside of the lines. You know, we're looking for abnormalities. But it's important to realize that at this stage, this calculation doesn't say anything about the underlying cause of the abnormality. It's just flagging something that's an outlier. So it's not telling us if it was doping, or it's not saying if there was a medical condition. That has to be assessed by a panel of experts. So really, there's 2 steps to this passport process. There's first a statistical analysis of the data, but then we need the human evaluation to come in afterwards and assess what what could be the cause of these abnormalities. And so this is what you'll hear referred to as the panel of experts. So a passport that's atypical will get sent to a panel of experts who have an expertise in, evaluating that type of data. And they'll be looking at basically three things. How likely is the passport if it's just a normal, healthy individual? Is that variation possible? They'll also evaluate how likely that passport is if there was a medical condition. So they could have a type of anemia or a blood disorder that would naturally, quote unquote, cause that type of passport. And finally, they'll ask, well, how likely is that passport given doping, if the athlete had doped? And they'll weigh these against each other, these different propositions. And what you'll see as an outcome from an evaluation of an expert are these four conclusions at the bottom. So this could be from your athlete passport management unit or from the experts. They'll use the same type of conclusions. And it would be that either the passport is normal, in their view, the passport is most likely explained by a normal condition. It could be suspicious. So there's some features that look like doping, but maybe they can't eliminate other possible explanations. But so nevertheless, they say it's suspicious. It could be that right away they can recognize that it's a medical condition. So the expert would say, conclusion is medical condition. Or finally, they might say that it's likely doping. And this we'll come back to after what happens if one expert says likely doping. It then triggers a kind of a cascade of steps that will continue this review of that passport. Passport process, this initial statistical evaluation and the expert evaluations all take place in ADAMS. And so each athlete has one passport. You don't want data separated across. And so each athlete has one passport and has one passport custodian. And so the passport custodian is very analogous to the results management authority. So for a sample collection, the testing authority would be the results management authority, so the one who's responsible for results management. In the case of a passport, well, you have many samples and possibly many testing authorities. So in order to assign a results management authority for managing a passport, there's still only one custodian. And this could be the IF, it could be the NADO, but somebody has to choose between them who is most likely or who should be the best passport custodian. And we'll talk about it a bit later, but it's usually the one who tests the athlete the most. Also in ADAMS, we have automated calculations. So all those statistics that the red lines and the blue, that graph is all calculated automatically in ADAMS and will send notifications when something atypical happens. The expert review that we talked about will also happen in ADAMS, and these experts will be blinded to the identity of the athletes. So they're doing this review in an anonymous manner. ADAMS also allows passport sharing. So if there's two ADOs, a NADO and an IF, who have a common interest in the same athlete, they can share the passport between them. So one would be the passport custodian, and he can then share, or he or she can share the passport with the other ADO. And finally, it allows WADA monitoring. And so we can have oversight to see if there are issues with ABP programs within ADAMS. So to give a sense of how the sequence works, the administrative sequence would look something like this. If we start on the left, when an athlete is tested, this sample would then be, the lab would analyze the sample and enter the data into ADAMS. And the passport would then be updated in ADAMS. So they would recalculate the limits for that individual. Then any notification, so if there's something atypical, a notification would get sent. In some cases, a notification for the steroid module, we'll get to this a bit later, but an automatic notification will get sent to the lab for a further analysis of that urine sample. And then if it's atypical, it will trigger a review by the APMU, this Athlete Passport Management Unit, or the expert panel if needed. And again, they'll have their conclusions like we discussed. Then following this review, the APMU will update what's called the APMU report. So there's just a little text box within Atoms where the APMU will give you maybe the most important part of the whole process, you know, for you, the ADOs, the NADOs. What you're really looking for is this APMU report. And this basically is taking all the expertise of the expert panel, of the APMU, of the lab, and they're trying to concentrate this into, you know, only the sentences that you need to know. And this could be, you know, test the athlete rapidly, or passport normal, continue testing. But it'll be a very brief 1 or 2 lines that will then instruct you on the testing strategy. And so here the ADO would adjust their testing strategy and then test the athlete again. And the cycle will continue, and we'd continue to add samples to a passport. If one of those the expert reviews comes back as likely doping, as I said, this kind of then triggers a particular process. So that passport would then get sent to 2 more experts. So if we have 1 who said likely doping, now it gets sent to 2 more who are unaware that the first review was likely doping. For them, they believe they're the first experts. So it's very independent reviews. And if they then also say likely doping, then what will start increasing the amount of information that we're giving to these experts. So the idea is to really, you'll see as we go along, to increase the amount of resources that are expended on the case. We don't go and collect all the data and information we can at the beginning because we might not need to. You know, if the case is not suspicious enough to advance, that would be a waste of time. So there's really a kind of, you know, slow addition of information as the passport case evolves. So the first piece would be then to provide a competition schedule to the experts so that they can see, you know, does it align with a period where they would want to be doping? Then the experts will confirm their position of likely doping. The APMU would then compile what's called the ABP doc pack. And this is, it's essentially a compilation of all the chain of custody, the transport conditions, the detailed lab analysis of key samples. And it's a large documentation package that would then be given back to the experts. And they can now look to see, you know, was the anomaly in the passport caused by transport conditions that were poor, or was it caused by an analytical issue, and so on. And again, the experts will confirm their position and write what's called the joint expert panel report. And so this is now the final report that will be used to notify the athlete. And so at this step here, we've arrived at what's called the adverse passport finding, an APF, which is a lot like an AAF in terms of substance detection. And at this point, the athlete will be notified. So there's still no ADRV, but we have this APF. The athlete is notified and given the chance to explain themselves. They may have a medical condition that's unaware to everyone that would explain this. And so they're given a chance to explain their passport. And then this explanation is reviewed by the expert panel, and a final decision is rendered whether or not to sanction the athlete. This, you know, is quite rare, as we'll see. There's been maybe 200, a little over 200 cases that have gone forward like this, and the majority are for blood. And so I know in many cases there's not, you know, a lot of blood testing for endurance athletes. in your region, but we are starting to see some cases like this developing for the steroid module as well. So it is something that could be developing as well for your cases. So in terms of what the ABP can detect at the moment, we have two modules. So the first module is this hematological module. So the aim is to detect blood doping, and the matrix or the sample type is EDTA blood or ABP blood samples, we call them in ATOMS. In 2014, there was the steroid module that was launched. And so here the aim is to detect steroid doping. And the matrix here is urine samples. And so this will be, usually what you'll encounter more in your region. And this is all urine samples. So every urine sample that is collected is analyzed and entered into the steroid module. And then finally, there's coming soon, projected for next year, so 2022, we have the endocrine module, where the goal is to detect growth hormone doping. And in this case, it will be serum samples or blood samples. So not EDTA or ABP blood, but the standard blood samples. And this, as I say, is projected for mid-2022. And all of this will be described very well, everything we talk about in the ABP operating guidelines. So I invite you to take a look in there for the guidelines section, but then also within these guidelines, we have all relevant technical documents that are appended as annexes here. So instead of having to go around and hunt down every relevant document, everything is housed within these operating guidelines. Okay, so now just to give a few, practical examples of how the ABP is used in practice. So the first example is as I discussed at the outset, the ABP can be used to directly sanction an athlete. And so even in the absence of detection of a substance, we can infer that doping took place. And so this would be a typical example here. You can see this is a blood or hematological passport for an athlete. And already, without even knowing what they mean, you see that there's outliers, right? There's blue that is going outside of the red for many of these markers. So something is going on. Now, ATOMS will flag these for the top two. It will flag all these and send automatic notifications. So these would get flagged the minute these samples were collected, analyzed, and matched with a DCF. These notifications go out, and these are called atypical passport findings, or ATPFs. And these will trigger that review process. So an expert reviewed probably the first sample here and saw that it's very low off score. And here that looks like stimulated blood cell production, which is very typical of EPO use. And so they requested additional samples, and then the hemoglobin went up, this is all very classic signature of EPO use. And so here, the expert review was triggered, and a sanction could be levied against this athlete. So this, as I say, has been used close to 200 times to sanction endurance athletes, mostly in track and field and in cycling. And there's been almost 20 different ADOs who have run this type of blood doping case. But arguably more impactful is the use of the ABP just to direct analysis of samples. And so to flag who is suspicious and then to do further analysis of those samples. So what we see here in green is the number of EPO positives. And in red is the number of those ABP cases. So where these Article 2.2 cases. So what we see at the launch of the passport in 2007, 2008, we see right away a doubling or almost tripling of the number of EPO positives. So just by knowing which athletes have suspicious blood values, you can go back and target that athlete for an EPO analysis And this has been arguably, as I say, one of the most successful aspects of the ABP, because over the years, this has resulted in hundreds of more positives than we would have had in the absence of the ABP. So the ABP can really detect what to test for. And the same for the steroid module as well. So as I said, if it's outside of the limits for certain ratios, we will get this automatic notification generated. And in this case, the lab will automatically analyze this sample by IRMS, and is essentially a method to detect testosterone. And in this case, the athlete was sanctioned. And so we see a relatively low value below the limits, the previous limits, but that flagged using the passport and then came back positive. And so this means they don't have to run all that type of passport case I was describing before. There's no expert review here because he's positive. It's a detection, an Article 2.1 case here. And there's even been some cases that were extremely low. To the human eye, it didn't look like much of a difference here, but to the passport, it flagged an atypical sample on sample 6, and this sample was positive for IRMS. And so again, this was an AAF, an ADRV based on an AAF for that sample. And what we've seen with time, well, across the launch of the steroid module, was that we detect many more of these very low samples or TE differences using the passport, and then just flag them using IRMS afterwards. The ABP also can direct who to test. So when you're doing your annual test distribution plan, one of the key aspects you should look at as part of that risk assessment is, well, who has an atypical passport? And that should be, if you have it in an Excel table or however you do your risk assessment, one of those columns should be passport status. And of course, the one who's got an atypical passport, you would want to test them more and allocate more resources. So the passport can also tell you who to test. The passport can also tell you when to test. And so it's important to point out that the passport, even though it's longitudinal in nature, it's not continuous. There's not a continuous amount of information on that athlete. And whatever happens in between tests, unless they're a day apart, whatever happens in between tests, we don't know. And so you can't assume that you're getting continuous knowledge on the athlete. So you have to plan your tests accordingly. And so what I like to think of as the athlete's kind of profile is like a dark tunnel. And every time you test the athlete, you're just lighting up one part of that tunnel, and you get to see what's going on around that. And the important aspect is if you do see something suspicious, that you have the ability as an ADO to then go and order rapid tests. And this is really how ABP cases are brought about, is this ability to put rapid testing into action. And what happens is the individual samples then provide supporting evidence of each other. And so you build what's called a doping scenario. And so like in the example I showed before, where we could see the high new red blood cells followed by the high hemoglobin, all those samples came together to make a story, which is really strong evidentiary proof of doping. Whereas if you just have one abnormal sample alone, it's very hard to bring that forward as a doping case. ABP can also be used to direct investigations. So it provides strong forensic evidence that can be correlated with other information. And this really, the power is to identify suspicious individuals or groups of individuals for further investigation. And so, well, this is maybe a bit, it looks a bit complicated, but this was a kind of investigation diagram where they're trying to layer all information into one image in order to decide, well, where is the suspicion here? And so they have different types of information, open source intelligence, their whereabouts, people who've had previous AAFs. And when they just layered on in yellow, the yellow circles were suspicious steroid passports or suspicious blood, you see that suddenly there's a group or a team here which, you know, we see a concentration of suspicious blood passports. And then this can be used to direct the investigation towards that team or that coach in that case. So this approach was used successfully in the Russian investigation. So in 2015, as part of the independent commission report, we screened for abnormal passports, you know, broadly in Russia. And what we found was that there was individuals with very low blood values, which is suggestive of blood donation, you know, for transfusion. And when we grouped them all together they were all the same sport. All the low values were from the same date and place. And so this was the Sarinx race walking training facility. And this allowed the investigators to then go with a specific mandate, you know, is there blood transfusion equipment? And they did find this on site. And so this led to, you know, the discovery of team level doping and the sanctioning of their coach, Victor Chegin. As well, more recently, Aderlas, you may have heard of the Aderlas scandal of blood doping, where there was a whistleblower involved. And so this whistleblower was actually previously positive. So he had been targeted around the Sochi Games based on a very atypical passport. And like I showed before, it was used, the passport, to direct EPO analysis. And so he was EPO positive at Sochi. And then when he returned to competition, was tested again, and then was also very atypical, his passport. And so he then started providing information and became a whistleblower here. And so the passport was used to identify the whistleblower, but then also after to direct the investigation. And so many of the passports here were atypical, and the passport could be used to provide investigators with lines of questioning, times and places, and especially because of the fact that blood withdrawal is very hard to hide. And so the passport was able to identify blood withdrawal in many of these individuals. However, as you might have been aware, reading the press around you know, Aderlas, that unfortunately the message to the athletes is not always the right one. I mean, the passport came under heavy scrutiny during Aderlas, surprisingly, you know, because we knew it was working behind the scenes. But you know, there was coaches of these athletes who wanted to kind of deny that there was anything wrong. And of course, this wasn't true. There were in fact red flags in these passports. And the unfortunate aspect of these coaches trying to defend themselves is that athletes lost confidence in the passport. Now, the steroid module can also be used to fight corruption. And this really stems from the fact that the steroid profile of an individual is like a unique identifier. It's a bit like a signature of that individual's steroid profile. So if you remember, I said on the first sample where we don't know the athlete's value, we have that large population range. So you can see that the range here an athlete could fall anywhere within this range, but their own range is quite stable for the individual athlete. So we can see that the combination of these markers can then be used as a bit of a signature or an identifier of that sample identity. And so this has been used to identify sample swapping. So where a DCO or an athlete has a means to swap a urine for another one. And so one example of this was in weightlifting, where an athlete provided a sample in competition that was very different than his normal values. And so this was analyzed by IRMS, and it came back negative. There was no steroids, no testosterone detected here. And so they continued to test the athlete, and again in the next competition it came back very high, and it was again IRMS was performed and it was negative, and the athlete was continued to be tested. But this time they also did DNA analysis, and so you can do DNA analysis on urine samples to identify who provided that sample. And what they found was that, well, these two were different from all the rest. And what had happened was these were actually the athlete samples in competition. And out of competition, he had corrupted his DCO, he had paid him so that he would swap the urines, but he was unable to do this in competition because, of course, you arrive and don't know the DCOs on site. And so this approach was then used more broadly, so we could screen for outlying urines. And as part of the recent Operation Arrow, it was called, where there was uncovering of these sample swapping, and they even had people who looked similar, and so the DCO couldn't tell them apart. However, by their steroid profile and DNA, we were able to distinguish them. So I hope I gave a few examples to start here about how you can integrate the ABP with other aspects of the ADO functioning. So the first one is to really be able to put APMU recommendations into action rapidly is really a critical point of the success of the ABP. And rapidly here means, within a few days. Often it to be able to test them again within a week is very is a very reasonable target for the success of the ABP here. As well as we mentioned, that passport status should inform your testing frequency. So when you're thinking of your test distribution plan, to use passport status. And as well to feed information from passports status to investigators. And as well, so suspicious passports, are often something that warrants closer attention. So in summary, one way I like to think of the ABP is really it's a tool to translate biological data into specific actions. So based on flagging of this atypical passport, this might trigger specific analyses, expert reviews, target testing, sample storage even, or intelligence gathering. And really the outcome could be one of many different types of ADRVs. And just a comment on the future, really, the ABP is providing a framework into which we can add any biomarker. So it's really a legal framework for the use of biomarkers of doping. And so the strategy is to continuously add new biomarkers that can detect new substances over time, so that we are continuously making it harder and harder for athletes to dope. And what we're seeing so far, to kind of echo back to the beginning of the talk, is we are seeing changes in athlete behavior. We're seeing reductions in atypical passports. We're seeing reduced effectiveness. Athletes are doping at different times, very far from competition now. It used to be that, the concentration of doping was really in the lead up to a big competition, but now some athletes are doping very far from competitions during training. And we're starting to see evidence on performances as well. So we're starting to push, the arrow down to increase the likelihood for clean athletes to win. So maybe I'll stop there. I don't know if anybody has questions before we move on to Norbert.
Thank you, Reid. I think before Norbert picks up and changes his slide, there's one or two questions. One question, Reid, was, is there, I think you have answered in your later slides, is there any time limit from likely doping to final decision?
That's a good question. And no, there's not a specific time limit. I think it really depends on the nature of that case. Some cases are very clean with few samples, and it's very obvious doping, whereas others may be more complex and have confounding factors. Altitude remains, a confounding factor that has to be dealt with delicately. So it's hard to give a strict answer. However, each step has reasonable timelines to it that should be adhered to.
The second question is, there was a case of this South African runner, Semenya, where testosterone levels were pretty high and she was considered not a female. Has the APB or APMU got anything to do with regards to this case?
No, it's a good question, and no, there was nothing with the passport there. And it's important to distinguish that what people talk about with the Semenya case is blood testosterone levels, whereas with the steroid module, we're measuring what is secreted into the urine, and they can be quite different. Somebody with high blood doesn't necessarily have high urine steroid levels, and so for her case, well, because she wasn't doping either, it was constant, whatever her level was. I honestly don't know in terms of urine passport, but it would have remained normal because there was, whether it's high normal or low normal, it's her natural levels, and so there would be no flag in that case.
Sure. The one more question. The last few days, there have been a case of an Australian swimmer, I think, who was finally got his case in CAS won, and I think it was a case of some thresholds. Are you aware of that case? And has APB got anything to do with regards to the threshold?
Yeah, also a good question. I only know as much as probably you do about the outcomes of the case. I haven't seen the decision, but no, I believe it was thresholds of detection in that case. So even when they're trying to detect the presence of a substance, you still need to have a marker or a threshold above which you can confidently say that it was present and within levels that would imply doping and not other explanations. And so I believe that's what the threshold would refer to in that case, the threshold for detection.
There's one more question that just came up. You mentioned DNA analysis been done. The question here is, does ADAMS also keep a DNA database?
Ooh, very good question. No, there's no place for the moment to store DNA information in ADAMS. And as you could imagine, that may be complicated. But it's important to point out that the DNA analysis that's used for forensic purposes doesn't tell you anything about the individual's DNA sequence. It just gives you some points of reference that allow you to compare between people. So you can't really, tell if somebody's going to have cancer or if they're going to get diabetes based on this type of DNA information. But nevertheless, it is, personal, private information, and so this would have to be treated accordingly.
Thank you, Reid. I think that has been wonderful. I think you need to stop screen so that Norbert can bring on his screen. To all of you who are attending, Norbert will be presenting the second portion. And in the third portion, there will be some case studies also. Now, if you do have any questions, feel free to unmute yourself and ask the question. I must also say the information delivered this far has been fantastic. I think we have not had a webinar on APB, on APMU, etc. in this region. I think this is the first time for this region, all right? And it is extremely important not only for test coordinators, but also for people who are involved in education, in doing the TDP, intelligence, etc. You can see how far it has gone, especially people in education. You get thrown all these questions to you. So please absorb it. And our key importance is actually giving this knowledge to our athletes and support personnel, as well as making sure we apply it. Yeah. Now over to Norbert. Norbert, all yours.
Thank you, Gabi. Thanks, Reid, for this always very interesting and great introduction. It's always a bit of a challenge for me to continue the presentation, but I'll try to keep you to keep you interested in that, especially because we are now going to speak about the ABP partners, which is also, of course, Reid described the full picture of the ABP and all the usefulness of the tools and the interaction of the ABP with the other anti-doping tools. But what is important also for you to know and to understand while we're speaking about ABP is who is involved in an ABP program. And because it could be seen as I would say quite difficult to have the full map. And this slide represents pretty much all the partners that could be involved in an ABP program. And we'll try to go through all of these little square and present you all the main roles of those partners. First of all, Reid mentioned the passport custodian, and to understand exactly what is the passport custodian, Reid already described it quite well. But so one athlete, one passport means that if the athlete is tested for urine or blood, there will be a automatically generated passport in ADAMS for steroid or hematological. And this passport, once created, will have a passport custodian affiliated. And the rules to affiliate the passport custodian are not so straightforward, but I would say, and as Reid mentioned again, the anti-doping organization which is testing the athlete the most should have the passport custodian. You can find the rules of attribution of the passport custodian in a dedicated place, and if needed, we can speak about that later. What is important also is the sharing of passport information, because one ADO will be defined as the passport custodian, but again, we all know that sharing of information on one specific athlete will be beneficial for all the anti-doping organization involved in controlling the same passports. So coordination, when we're speaking about ABP program, is also a key aspect. So passport custodian is responsible of the result management after an atypical passport finding has been issued by the athlete passport management unit. And again, this is very important for the passport custodian to be aware, because there are quite a few administrative steps to fulfill in those atypical passport finding cases. So I just mentioned that before. So normally the passport custodian is attributed to the testing authority that first tests the athlete. So independently if the first test is a urine or blood. Okay, there are exceptions, but if you keep this, I would say this criteria, it's a good starting point. What is also really important is when we're speaking about the passport sharing, we are more speaking about the read access. Importantly, you need to know that there is only one passport custodian per passport. And you will see that having one passport custodian, there is only one APMU that could review the passports. So if you want to share a passport with another IF, for example, because they are also testing the athletes, the IF will have a read access to the passport, but the APMU affiliated to this international federation won't have access. So there is only one APMU reading the passports and giving recommendation in NADOs. So what about the NADO and the IF? The ABP guidelines were already mentioned previously in this presentation, and I can only confirm what Reid mentioned. Just go through those guidelines. It's a really good summary, and you will find all the related documents in terms of international standards, result management, testing, and also analysis for the laboratories. One of the main points for the NADO and IF, and here we're speaking also about the passport custodian, is to contract an APMU. Actually, currently we have 16 different APMU. I'll come back on that later. But this is the, I would say, one of the key points to run an efficient ABP program. Reid emphasized, and it's true that the experts has a key role in a passport management, but the expert without an APMU, they are not useful because experts are contracted by the APMU. So passport custodian will contract an APMU, and the APMU will be in charge of hiring experts. To have an efficient ABP program, the passport custodian, it could be NADO or IF, has to follow the recommendation. I would say it's not a shall, but it's highly recommended. Why? Because you have seen in Reid's presentation that ABP has been very useful to deter doping in different situations. Being the passport custodian, of course, you have to implement a test distribution plan, and I highly and strongly recommend to contact your APMU through the RADO or your own APMU in order to first establish the contact with the APMU, know the people you are speaking with, and also they have the expertise to support and to help you to implement the test distribution plan. So strongly recommended to have a direct contact with your APMU. We have also seen that investigations have been directed thanks to the passports. So definitely very important to manage the ABP program. And we already spoke about that the passport custodian has to follow up the result management after an adverse passport finding. And of course, informing the athlete is part of the result management, as already seen in the previous slides. So now I think it's quite relevant here to speak about the delegated third parties. And in our situation, we're speaking about the RADO. Since January 2021, the RADO has become the delegated third party. Being the delegated third party prevent the RADO to be the passport custodian. That means that the NADOs themselves became the passport custodian of their own athlete that were previously managed by the RADO. So our colleagues from the NADO-RADO department are very active in terms of contacting the NADO in order to encourage them to delegate the ABP program to the RADO as it was previously done, if it was the case, in order to have a centralized management of the passport. And because the RADO used to do that ABP program management, it's a good solution for small NADOs. So what are the roles of both parties? And this has been provided again by our NADO-RADO colleagues. So the NADO has to provide ABP access to RADO in ADAMS. So we'll have a very brief slides on ADAMS. But the main thing you have to keep in mind is that if you have any troubles with ADAMS and giving access to the RADO, there is a support team within WADA, which is quite responsive and very helpful for those technical aspects. NADO has to provide also RADO with a copy of the APMU agreement, because there are two different scenarios. Either the NADO has an agreement with an APMU or they don't. And in those cases, then the RADO will select and contract an APMU for the NADO in collaboration with the NADO. So these are the two different scenarios. Again, as a reminder, there is only one APMU that could have access to the passports. So you can't contract two different APMU. There is again one exception, which we are not promoting, but I'm just mentioning it here. One APMU could manage the steroid passports, while another one could manage the hematological passports. But why we're not promoting this? Because we have already seen that there is a very nice and big interaction between both models. So having only one APMU managing the steroid and the hematological model will facilitate the communication and the management. So the RADO, they will collaborate with the NADO regarding the strategy, how to implement the ABP program. And after having the correct setting in ADAMS, the RADO will receive and review the APMU recommendation and perform the follow-up actions, as we will see later, which kind of follow-up action they have to follow. What about the labs? So shortly, the labs will receive either blood or urine samples, and they will analyze them in compliance with the appropriate technical documents. Regarding the ABP, a lab will issue administrative documents to compile in an ABP documentation package by the APMU, and also the lab will provide additional information if needed for passport interpretation. Here, I would like to repeat a very important aspect. Once a sample, an anti-doping sample is collected, it could be sent or shipped to any of the WADA accredited laboratory, independently from the APMU agreement. So if you collect the samples, you can send it to any WADA accredited laboratory, and once the analysis is available in ADAMS, your APMU, and there is only one, your own APMU will have access to the passport. You are the passport custodian. We have noticed that it's not really, I would say, known that the sample analysis is independent from the passport interpretation. So ABP experts, I won't go into details for that because Reid covered that quite well. Again, the experts are hired or say contracted by the APMU in collaboration with the passport custodian, and of course the experts are a crucial role in passport interpretation and I would say evaluation of the likelihood of doping for an athlete. Now the APMU, so the APMU, so the Athlete Passport Management Unit, are in charge of a timely management of the passports. And I'm coming back to the question raised during the first part of the presentation. There is a kind of timeline for passport management in terms of I would say evaluation in ADAMS, evaluation by the experts, but then of course when it comes to the I would say administrative burden, compiling the ABP doc pack, then sending the APF to the passport custodian, contacting the athlete, having their or its explanation, sending back to the expert panel. So that is not, I would say, described in the document, and that's the parts taking the most of the time of the result management. So what are the outputs? the outcomes of the APMU works in ADAMS. So they are issuing, so they are writing APMU report in ADAMS, and this is mandatory for the APMU. And this is why it's crucial for the passport custodian, being a NADO or a RADO or an IF, to have the correct setting of ADAMS accounts. Because if you don't have the correct settings, you won't receive and you won't see the APMU reports. And because these APMU reports contains all the follow-up actions, recommendation, you have to have access to those reports. So they are issuing the adverse passport finding, and then of course before that there are these atypical passport findings. So when the blue line is outside of the red ranges presented by Reid, that means that it's an atypical passport finding, and there are criteria for the APMU to review those kind of ATPF. Also, a very important aspect for APMU, and this is a bit too technical, but we have the sample validity in ADAMS. So urine and blood samples could be valid or invalid depending on transportation condition, analytical results, any other kind of criteria. And the APMU has the ability to validate or to invalidate samples according to their knowledge, to their expertise, and also in consultation with the experts. And as I already mentioned, an APMU has to provide support to the passport custodian in terms of optimizing the efficiency of the ABP. I would say advising spatial analysis, test distribution plan, and target testing. And I repeat myself, sorry for that, but please contact your own APMU, have a direct relation with them in order to increase the efficiency of your ABP program. So when we are speaking about follow-up actions, what are they? Which are they? So we have two different models at the moment. So speaking about the hematological model, we have three different kinds, I would say, three general follow-up actions that an ATO should follow. First, the APMU could ask to collect additional samples. And we are educating the APMU to give as much detail as possible to help you as the passport custodian to collect the right sample at the right time. I mean, they have to provide the matrix. They have to provide if it should be in competition, out of competition, in terms of timing, if it's reactive testing within 2 days, 1 week, or before the next competition, in order for you to be conscient of the timing of the test. Of course, because hematological model is focused on the blood manipulation, then we can have ESA analysis in urine, in blood, in serum, depending on the matrix that are available for specific samples. And also, and we have seen recently that two homologous blood transfusion has been detected. So blood transfusion analysis could also be performed on ABP blood samples. Regarding the SEARADO model, we have a little bit more of actions that might be some, I would say, administrative, because there could be some possible mistake between the match of the DCF and the athlete names, for example. So if the match is not correct, speaking about the SEARADO model, we could have huge differences between two different samples. And in fact, it's not a doping scenario, but it could be that the DCF was wrongly matched to the athletes. There could be also some issue with the lab reports in ADAMS. So it could be requested by the APMU to confirm the correctness of the ADAMS data. Then, of course, if it's an atypical passport finding, it could be the steroid profile confirmation, and then the GCC-RMS, ultimately, and if necessary. We mentioned the DNA analysis. There are also the collection of additional samples. And last but not least, but very important, and we observed also, we noticed the crucial part of the storage. We all know that the storage of samples is quite challenging for testing authority. but sometimes having the samples stored for a longer time than the 6 months mandatory, 3 months or 6 months indicated in the international standard for laboratory could be beneficial for ABP cases. So how the APMU report looks like in ADAMS, and this is a screenshot of an ADAMS APMU report. So you have different parts. First, you have what we call the APMU report in the comment windows here. Then you have the report history, meaning that every time the APMU will submit a report in ADAMS, you will have all the history for this specific passport. Of course, you have the recommendation, if it's normal, if it's suspicious, if it's likely doping, likely medical condition, etc. As we already spoke about that before. So this recommendation is quite important for you to define the test distribution plan. And this part is not available for the ADO, but it's available only for the APMU. And then here you have a kind of button, the APMU have access. You don't have access to that because it's to assign the passport to the expert for further evaluation. So that's pretty much how it looks like in ADAMS. What is important for you is to read really the comment and the recommendation of the APMU. I already mentioned that we have currently 16 APMU, approved APMU. All these 16 APMU are spread around the world, pretty much. We have quite a few in Europe. We have 3 in Asia, 1 in Oceania, and 2 in America. All these APMU are hosted by a WADA accredited laboratory, and you can find the list of the contact, especially for the director of this APMU, on the WADA website. Why did we decide to center all the APMU in the labs? Before 2019, IFs, ADOs were able to have internal APMU. But then we realized that having all the APMU hosted by the labs have a lot of advantages. We all know that the scientific expertise is quite concentrated in the lab. Laboratory staff members are analyzing samples. They are all aware of the published research. They are all aware of the analytical issue that could raised regarding a passport evaluation. We observed also that there is a very low turnover of laboratory staff, meaning that the knowledge is maintained within the APMU and the laboratory. One of the key aspect is the independence from the ADO. So you'll have, if you have an APMU hosted by the lab, and the APMU is working completely anonymously, you'll have full independence from the ADO, which is also very important for the ABP process. Again, APMU is independent from the lab. Samples can be analyzed in any labs, while an ADO is in agreement with one APMU. Okay, this is very important to remember. So finally, to conclude, and this is just a repetition of what Reid presented, we have an administrative sequence involving different partners, which has very well-defined roles. And if all the partners are respecting their roles and doing their, I would say, doing their job correctly, then we will have a very efficient ABP program. With that, I'm done for the ABP partners. I don't know if there are any questions on that.
Thank you, Reid. Very interesting. Yes, there has been some questions. All right. The first question is it advisable to have the same lab doing the urine analysis, doing your APMU? And the question they ask is there a possibility of a lab asking NADOs to do additional tests as they would like to increase their business?
Okay, no, good question. So, well, it's again, and I think I try to explain. the APMU work is completely independent from the laboratory work. So anti-doping samples could be analyzed, let's say, in Paris, in France, samples collected by, I don't know, one of your country in your region. And because the athlete was based in France for training for a competition, whatever, it's easier to send the samples to Paris instead of Sydney, for example, for cost and logistical reason. Once the Paris labs would have analyzed the sample and entered the data in NADAMS, the APMU, wherever it is and whichever it is, will have access to this to the data in NADAMS. So if you are contracting, let's say, the Sydney APMU, once the Paris labs will enter the data in NADAMS, the Sydney APMU will receive a notification that the sample has been matched with this passport being under the custody of this country who tested the athlete. So there is a complete independence. So you can do whatever you want. And because there are less APMUs and labs, it's also very interesting for the testing authority and the passport custodian to have those independence. Otherwise, it would be quite tricky.
Second question is with regards to passport custodianship. For international athletes, do you reckon it is best for the IF to be the passport custodian?
Here, I would say it depends on the who is testing the athlete. If it's an international athlete, I would say a high-level international athletes, most probably the international federation will test her or him on a more frequent basis. Then I would advise to have the international federation of these athletes being the passport custodian. But if it's an international athlete competing, I don't know, once or twice a year, because it's I would say, a less popular sport, having only one or two international competition, and the athlete is training or competing locally in the country, then the NADO could be the passport custodian, because to test the athlete, it would be more efficient for the NADO to have the passport custodian. It's really a case-by-case evaluation, I would say, and that's why we are saying the general rule. Usually, the ADO, which is testing the athlete, should be the passport custodian.
Thank you. One more question here. Do all athletes need to have an APB, or are there only a specific group of athletes that need to have APB?
All athletes tested will have a passport created in NADAMS. So the APMU will have access to those passports, but then it's also up to I would say, the passport custodian to agree with the APMU if they are willing the APMU to review all the passports, because most of the passport will be flagged as normal by the adaptive model, or if they are willing the APMU to review very specific passports. But every athlete tested will have a BPID. A BPID is I would say, a sequence of letters and numbers to identify the athletes on an anonymous basis.
Great, thanks. Thanks, Reid. I think you got one more portion to go. Am I right?
Yes.
Okay.
Yes.
As you move on to that, I have a question for Reid. Reid, are you still there?
Yep.
Initially you mentioned about population limits with regards to testosterone, etc. Now, are these population specific, or is this a generic worldwide population limits? Because maybe certain population will have higher limits compared to another set of population. Your thoughts?
Yeah, fantastic question. And really, it was maybe part of the evolution of the population limits was exactly that, to try to have local or limits based on different ethnicities. So originally, no, there was no different limits based on ethnicity, and we know there are certain populations that have naturally high TE ratios, or naturally high, not just individual, but that whole region may have them on average higher. And so there was an attempt, a kind of intermediate step before the passports to introduce that. I don't think it was ever used in practice. It was proposed, you know, because scientifically it made sense to some degree, but it still fell into the trap of not being individualized enough. You know, even within those populations, there's still a variety of values. So it was still difficult to apply a single rule, even within one ethnicity.
Great, thanks. All right, Norbert, I think you can go to the last part, which is the APB cases. I'm sure a lot of you will find this interesting because these are real cases. Having said that, I just want to remind all NADOs, make sure you do have a contract with an APMU, with a lab. I got a strange feeling there are 2 or 3 of you who said you're going to have a contract, but you have yet to sign, and having to put the right settings if you have already got the contract in the Adams. Yeah. All right, Norbert, all yours.
Yeah, thanks. I think we are running late, so maybe we'll we'll skip the first slide, even if it's quite important. You just mentioned that, but we have just a few slides. Yeah. There is a very well, I would say, documented website called Adams Docs, and I strongly recommend to go on that website. And there are a lot of information and guidance for you to set up Adams in the correct way. And if you have any question, don't hesitate to contact the Adams teams at the email address indicated here. Yeah, Adams accounts. You centralize all the anti-doping activity in Adams, and I won't repeat that, but it's definitely a key tool to have an efficient and to coordinate the anti-doping program. So go on Adams, make it running well, and your life will be easier for sure. That also I will skip because we mentioned that already. So there are 3 different matrices of anti-doping samples. Urine is the one considered for the SEARADO model, while the blood EDTA is for the hematological model. And the analyses are performed in WADA accredited laboratories. Yeah, I think I'll give the floor to Reid, because we'll now try to go through one specific hematological passports and to go step by step with the expert's explanation and the APMU evaluation. Reid, are you ready for that?
Yeah, thanks, Norbert. Yeah, and I see the time. I mean, this will take a couple of minutes to go through, but we may be a little over. So I hope that's not too much of a problem. We tried to just choose a case. I mean, it's easy for us to show examples that are textbook examples, and we didn't want to give you a kind of false impression of how the ABP works in practice in the real world. So we have one kind of more complex case here, but it really shows many different real world aspects to the ABP that you can encounter. And so this was a blood passport case. But again, you know, the concepts can apply to either module in general. This was a swimmer, 24 years old, and we're going to just go through how this passport develops over time and in response to the APMU recommendation. So it's really to show you that kind of back and forth interaction with the APMU. So this was the first sample in this passport. And already there was one, you know, some of the values were tending towards the upper bound. So that off score was looking kind of high. And so the APMU noted this and said, okay, more samples are needed. And they said, as the athlete has been apparently competing recently, that they should take the next sample within the next couple of weeks. And so here it was right away, okay, to collect a sample rapidly, and they would do an ESA if possible. And you can see at the bottom too, already the recommendation to store samples. So, it doesn't take 50 samples to start needing to be reactive. Already after the first sample, the APMU's made 3 recommendations for reactive testing, sample analysis, and sample storage all at once. You can go ahead, please, Norbert. And it was good. They were very reactive and collected this next sample. So I believe the day 0, it's the time period between that we've just added on top. That's not normally in there, but so you see they managed to get a sample 16 days after the first, and it had a very abnormal value. And so this again triggered the APMU to request yet another sample. So they're trying to do like that image I showed of getting a series of samples that can together make a cohesive story. And so they collected the 3rd sample, and quite rapidly, you could see, so day 24, so within 8 days, the sample had been collected. So that's great. And we start to see again this return to normality. So there's really a nice picture of blood values changing over time here. There was a little hiccup we can see with sample 2 became invalid because there was the temperature logger for that sample that showed that it might have gone below 0. And so here the APMU is asking for the detailed logger information for that sample. So the direct file for that sample. And then again, collect another sample. And here they give a bit more time, and they say keep all urines as well. So now as we move on, the 5th sample was collected. We can see there was another one in the interim, sample 4, that was tried, but then the collection to analysis time was too long. So there's criteria, as many of you might know, for the time between collection and analysis, and if it's too long, the sample is just unfortunately invalidated. And this is, one of the realities of testing for the blood module. It can be very difficult depending on where you're located and where the lab is located. And so that sample 4 was a lost sample here, and sample 5, was still within the normal range for that athlete. They collected again another. And by now, what is happening is they're kind of establishing what are normal values for the athlete. And it seemed like clearly this constellation of 3 samples at the beginning was atypical. And so now we've started to see for the first time, it was sent to an expert who says likely doping. And it was sent to 2 more experts. And now we have a unanimous likely doping based on these 5 samples, and the one invalidated sample. So here they, as we mentioned before, they have to collect all these documentation, the ABP doc pack, and share this with the experts. And what happened at this stage, wait, where are we now? Unanimous likely doping. So the case is still going, and they held a conference call between the experts so they can continue to discuss. But the view was that they were not quite ready to go ahead. They wanted to see a few more baseline samples. There was a bit of uncertainty about what was really normal for that athlete. And that is important, that they can be confident about what is, the baseline for that specific athlete. So they again went back to test a little bit. So more tests were added to the profile that were again confirming the previous ones. And so again, more samples. So a nice, very steady baseline is shown. And again, yeah, we could see, I think the experts were getting as many baselines as possible. And what happened was that there was just not a confident understanding of where the normal levels for the athlete were. And so this is something that can happen, is that the panel is no longer unanimous. So one of the experts was not confident to go forward with the case. He didn't find the evidence sufficient to sanction an athlete. It was clearly suspicious, but it's, you know, an important principle of the ABP is to always err in favor of the athlete, and avoid, you know, the famous false positive. And so in this case, one of the experts did just that, and was cautious about moving forward. This can be extremely frustrating. For you as an ADO, there might be other information that would, you know, lead you to believe the athlete is suspicious. But at the end of the day, this panel of experts are the ones who go to CAS or go to the hearing with their reputations on the line, essentially. I mean, they're a little external to the system in that they, you know, there are professors, or they have other careers, but they have an expertise in this anti-doping. And if they're not comfortable, you know, to go and defend a case at CAS, we have to respect their, you know, their view and expertise ultimately in that. But, you know, this is, again, kind of a real world potential outcome here. So as kind of conclusions, you know, key points, what we did see from this case was this intensive follow-up of a suspicious athlete. So they were tested, you know, many times based on that suspicious initial values. We saw really nice reactive testing. The ADO was able to put into action, you know, quite rapidly some testing. As you see, we're not talking about 48 hours, but within a week or two, able to get those key tests made a big difference. Honestly, if they could have gotten a bit sooner on some of those early tests, that might have changed things, to be closer to a week between sample 1 and 2, and then even the third might have changed things. But again, you know, there are positive outcomes that come from cases like this, even though we didn't sanction the athletes. One is the deterrent effect. We saw that passport, you know, normalized right out now that the athlete was being highly tested. There was no more of those variations. So clearly the athlete knew that you know, they were now being tested. They were under the radar, so to speak, or on the radar. And there was also the possibility for further intelligent testing for that athlete, urine and blood. And the samples are now stored. You know, just because the case didn't advance doesn't mean you should discard the samples. Quite the opposite. You know, keep samples and continue testing that athlete. So I'll hand it back maybe to Norbert. If you want to quickly do the last case. Is that okay, Gobi? Do you think timing wise?
Okay, time-wise, we are a little tight because 2 hours has run. All right. But Norbert, just go ahead. I think it is good for us to know the case. Yeah. Yeah,
well, it's only a couple of slides, so it's less detail as the blood cases. Yeah, well, here we wanted just to show you 2 different passport cases for SEARADO model. The first one on the left, you can see that 2 points highlighted with the green circle. Actually, those 2 samples became positive for GC-C-RMS analysis, meaning that those samples contain testosterone that were taken exogenously by the athlete. And those, you can see that those samples were clearly highlighted and triggered by the adaptive model, because they are higher than the upper limits of the model, okay? meaning that they are not in the range, within the range of the two red spots, but they are higher. And because they were higher, the labs received an automatic notification to proceed to the third profile confirmation and IRMS. Also, the APMU could be consulted by the passport custodian in order to confirm that in sometimes the RMS shall be performed. The other case on the right is a passport. You can see that the first point had a T value higher than the following one. But this first point is still within the individual variability because it's in between the higher and the lower limits. What it made here, just to give you a kind of idea of the timing, between the first and the last point, there is a period of 8 to 9 months. So meaning that this athlete was clearly targeted. And at the time of the first test, the APMU advised the passport custodian to keep the sample in long-term storage because it was the first sample. And then after the second one, we can see that the T level of this athlete is clearly different from the first one. So what they did here is they built the baseline value with the sample 2 to 10. And after that, they decided, okay, let's go back to the first sample and proceed and perform the GCC-RMS analysis. And they were right, actually, because the samples turned out positive with GCC-RMS. So here we have two different cases. One, the RMS is targeted by the adaptive model with the support of the APMU and the labs. And the second one is not flagged by the adaptive model, but the APMU did the correct action and the passport custodian as well. So yeah, again, the SEARADO model is very useful to target suspicious athletes, to perform and to proceed with GCC-RMS. We all know that GCC-RMS is not the most the cheapest analysis, but it's obvious now that RMS is one of the most efficient, I would say, methods to detect doping with testosterone. So the role of the ADO, again, is to follow the ADAMS notification, APM notification, and also to contact and to be in contact with the lab analyzing the samples to approve the GCC-RMS if needed. Sometimes it's mandatory because the labs has to analyze the samples for RMS, but also for the long-term storage management. So be patient, be proactive, and have the correct ADAMS settings and follow the APMU recommendation and be in contact with the labs and all the different partners of the ABP program. That would be the conclusion.
Thank you. Fantastic. Guys, to be very honest with you, to both of you, I mean, a big round of applause, although it's virtual. I know it's way past 10 p.m. in the night for both of you, just for the benefit of all our people. Both the speakers have taken their effort and their time in the evening at way past 10. And I must really say this, that this has been one of the most informative webinars we had in this region with regards to APB, APMU, giving a good insight on all these matters. And we are represented by almost all our NADOs in the region, as well as some people from outside. And I think this provides a very, very good information with regards to this. There might be one or two questions as we receive lots of APMU recommendation. Do we have to follow up the recommendation? Obviously, I think you need to follow up. There were one or two questions. I'm trying to read the questions now. All right, you do have to follow up the recommendation. Reid, I think there's someone who just came in and asked a question whether NADO officers are supposed to be able to read it. I think you came a bit late, Visa, and I think you're relatively new to this because I think it has been clearly covered in the earlier portion of the lectures. Now, following this, Sui will probably be providing you a survey. And if you complete the survey, we will give you access to the recording as well as the slides so that you can take time to digest and understand, because I do know in many of your countries, you need to digest it and translate it to your own language to ensure people understand on the ground. Reid, Norbert, I have just one request. We do have education people here, all right? This has been a tremendous amount of good information. But if these education people were to go out there and present something on this, it will be great that there can be a simple consolidated information, all right, as to what they can present to the audience, in the case athletes as well as support personnel. Obviously, they can extract things from your end, whatever you have presented, but it will be good if you can let the education people know, all right? So that's basically what I have. People, we will look through your chat questions, which we have way past the time. 2 or 3 important things. Look at the operational guidelines, look at the Adams document for you to have a further insight, all right? Last but not least, which is a norm in this part of the world, can we get all your video on so we can take a couple of screenshots? I see Marielle adjusting her hair, all right? All right, if you can have all your video on. Okay, I think, Sue, I think there's 2 or 3 screens. Huh? There are 3 screens. Sue, you ready to take the screenshot? You can just move around the screens. Put on your great smile.
Yeah, I'll take the screenshot.
I'm very sorry, I don't have a camera.
It's all right. You got your name there.
I just to give you the smile, which smile, but I don't have a camera on my computer.
Okay. Done.
Done. All right. Thank you very much, people. But before we move on, all right, we'd just like to highlight to you our next webinar, which is pretty interesting. So you want to put that up? This is our next webinar for next month on the 25th. It is a collaboration with ASEAN as well as FIFA, all right? And a couple of areas will be covered, very brief with regards to resource management, a little bit about TUE. So we can't see your screen. So if you have an interest, I think she's trying to show a screen, but I think it is not showing, but not to worry. We just have actually a flyer there. If you are interested in attending that seminar organized by ASEAN, SEARADO to SUI, all right? If not, if you got any further questions with regards to APB, APMU, I know a lot of these words might be something new to some of you. Take time, complete the survey, listen to the webinar again, and translate the necessary stuff so that everyone can gain a good understanding on this. All right. With that, thank you very much and have a great week ahead.
Thank you very much.
Thank you all.
Thank you all. Bye-bye.
Thank you all. Thank you, Bobby.
Thank you very much.
Thank you. Great.
Thank you.
Thank you very much.